Welcome back to the video series. Today we'll be doing repeated measures ANOVA. Sometimes this is known as within subjects or within groups ANOVA. In this case, we don't have multiple different groups participating in the experiment, but we have one group doing multiple trials representing several levels of the independent variable. So, in this case, imagine an experiment where you want to test the impact of sleep deprivation on a cognitive skills task. With this particular cognitive skills task, the problem with it is that between or across different individuals, there's a great deal of variance or variability in their performance on that task. So if you remember, this effectively equates to noise. The more noise that you have when you're doing a statistic, the harder it will be to find the signal or the effect of sleep deprivation on cognitive performance. So we don't want to worry about the variance across people. We want to focus on the change in performance that is really primarily coming from sleep deprivation. So in order to maximize this, what you have is sleep deprivation, and you bring in individuals and you have them basically complete the task. These 8 individuals, you have them complete the task after 24 hours of sleep deprivation. Then the same 8 individuals do the task again after 48 hours, and then finally after 60 hours. Therefore, we are going to have variance or performance differences across those 8 individuals, but it will only be across the 8 individuals. If we had 8 individuals, then a different 8 individuals doing it after 48 hours of sleep deprivation, then not only do you have the differences because of the difference in sleep deprivation, but you also have the differences because you're adding new individuals in that second task. By keeping the same individuals at 24, 48, and 60 hours, you're basically minimizing the noise across those levels of the independent variable. Again, the independent variable here is sleep deprivation. The levels would be the 3 different amounts of sleep deprivation. So as we move forward, this is our easy ANOVA table for within groups or repeated measures ANOVA. What I want you to do is take a moment to notice I have this all in yellow because this is exactly the same computation as what you did on the between groups or or the one-way ANOVA. So if you are not familiar with that, I encourage you to watch that video because we will not be reviewing these computations in this video because it is effectively exactly the same thing as what you've done before. What we are going to be adding is this between subjects line here, and so this will be a novel computation which is often subject to some confusion, and there is one area of this computation that causes my students problems in the sense of they just kind of forget what the step is. So we will spend time talking about that, but effectively the table looks very, very much the same. So going back to our story problem, again you have 8 participants and they are existing or doing the task, the cognitive skills task, under 3 different aspects of sleep deprivation. So we have 8 individuals, and I want you to notice that I have P1, P2, P3. Again, as before, that's participant 1, participant 2, participant 3. It's just shorthand for using that. Why am I using the word participants instead of subjects? Common convention in psychology is that if it's a non-human subject, it would be referred to. If it is a human, they would be referred to as participants at this case. So effectively, I have the first condition under 24 hours of sleep deprivation. These are the number of errors that they have committed. After 48 hours of sleep deprivation, you see the number of errors that they have committed on the cognitive skills task here. And then finally, down you can see that after 60 hours of sleep deprivation, those are the number of hours. So what we have done here is provide you the boxes and the notation down below for the computation for between subjects. So again, I'm not going to spend time reviewing it, but I've provided the information and in the boxes for you to compute both between subjects and within subjects. So for between subjects, you're going to need to add them up, get the n, get the mean for each one, and then finally you're going to need to do the x bar minus g bar squared computation. And so I encourage you to pause the video for a moment. See if you are able to do this with just your easy ANOVA tables. If you're taking my class, I've provided those for you, so you'll be able to print those out, or if you need to, you can rewind so that you actually have the formulas on the screen. So now if you've come back and you've done those computations, then all of those should look like this. And we are then going to take the sum of squares for between, and we are going to transplant it to the easy ANOVA table. But before we do that, we need to calculate sum of squares within. So remember, the sum of squares within formula is just calculate the sum of squares for each individual group, or in this case, level of the independent variable. So as always, you're going to take the errors, you're going to subtract the mean. Once you get that value, you're going to square that value, and then you're going to add those all up, and you will do that for each level of the independent variable. Once you have all three levels, as you see here, you're going to want to add those together, and that will give you the sum of squares within. So again, if you have your table available, your easy ANOVA table, I encourage you to take a moment, practice calculating your sum of squares for each individual one. And now if you've taken the time to do that and you're back with the video, these are the values that you should have come up with, and so in the end you will see a sum of squares within of 68. So we are of course going to want to transfer those to the easy ANOVA table. So sum of squares between, as we had calculated a little bit ago, is going to be 121.33. Then finally sum of squares within, which we just calculated, is 68. Remember the degrees of freedom as listed on your table. It's going to be it's going to be k minus 1. K is going to be the number of groups, or in this case levels of the independent variable. So that's going to be 3 minus 1 equals 2. Then we're going to have capital N minus k. So we had a total of 24 individuals minus the 3 levels leaves us with 21. So that fills in that top part of our table. I do want you to take a moment to notice here that between and within are basically at this level, and when we get to between subjects and error, those are indented. This is another area of confusion at times. What I'm going to do is the total within subjects variance, sum of squares, I'm going to divide that into two components. I'm going to take that amount and it's going to be divided into between subjects and error. So that's why it is indented, is to indicate that these are subsets of within. Sometimes when individuals add their sum of squares to get the total, what sometimes my students do when they make a mistake is they add between, within, between subject, and error, and by so doing they're effectively adding within subjects variance twice, because we take it, we have it here, and then it's subdivided into two different components. So as before, to get total, you want to add just between and within. You do not want to add between subjects and error, because again you'd be adding that in twice. So between plus within will give you that, and as before on the table you do have that total formula. So you can do simply x each individual score minus g bar squared, and then sum those all together to double check your results. So now as we move forward, we're going to be wanting to look at this between subjects formula. So what P represents, and I want to take you back for a second, is that is the sum of the scores per subject. Up to this point, we have largely been adding the columns and going vertically. If you recall, when we did a repeated measures t-test, we had to subtract horizontally, or take the before score and subtract the after score from that. With the repeated measures ANOVA, we will be doing the same thing, but because we have multiple groups, we won't be subtracting. We will actually be summing that row total, and that's going to lead us to effectively the same thing that we're doing in the different scores, slightly different with a repeated measures t-test. So what that is the row totals. Here's the other thing that gets a bit confusing. P in the formula is that final row total. So it does get confusing because we have participant 1, participant 2, participant 3 for the 24-hour group. We have participant 1, participant 2, participant 3 for the 48-hour group. These are not the P scores that we're interested in. Oh, that takes me back to Star Wars days. These are not the droids you are interested in. So really what we should have is an extra notation here. So basically P11, participant 1, group 1, P12, participant 1, group 2, etc. But we're trying to keep it a little bit simple in terms of subnotation. Eventually, the P values that we are interested in here is once we add all of those values, that will be our first row total. So this is no longer participant 1. This is going to be the total for participant 1. So this is the P value that we're interested in this case. So notice I have for participant 1, they got 3 errors, then 4 errors, then 7 errors. To get that P1, it's going to be 3 plus 4 plus 7, that gives me 14. So the first stage is simply adding across all the individual participants to get those P total values. The first part of that equation that we saw before is right here. That is sigma P squared divided by K. So remember, order of operations. We're going to do the exponent first, then the division, then the summation. So what happens is we have 14 for our first value. We're going to square that, get 196. Then we're going to divide by 3. That's going to be k, the number of groups that we have, to get 65.33. We will then do that for the second row total all the way through until we finally add those up. And in this case, we get this nice value of 464. So after I have summed, meaning I've got the p-values, be careful here, because this summation indicated by the formula is talking about adding all of these final fractions together. So to get to the p-value, I don't actually have a summation for that. You just have to remember that p is the row total. Add them all together. This is the step on a test that my students most often forget. They can calculate the rest of the table, but then they see that p squared, and they ask themselves, where does the p come from again? So they have to remember, oh, do the row totals. Again, it does say on the table, if we go back for a moment, it does say down here, sigma x per participant. So the notation is there. You just have to look for it and find it and remind yourself, do the row totals, then do this part of the formula. So they add it together, get 464. We now have the first part of that overall formula. The second part is g squared divided by capital N. G is the grand total. We're not dealing with a mean right now, it's just the grand total. So another way of saying that is, what is all of the errors added together? So basically I would add all the columns of errors, 3 plus 2 plus 0, etc., 4 plus 3 plus 3, all of those together. That's going to give me G. So in this case, it turns out that the total number of all those errors is 100. And then I'm going to need to divide that by capital N, which is the total number of observations. So that's going to be 100 divided by 24. The other mistake most commonly made that students make is you only subtract that g squared divided by capital N once. So after you have summed all of these up, then you calculate this fraction and subtract it once. The mistake that students make is, in this case, g squared, 100 squared divided by 24 ends up being 416.67. What my students will do is take 65.33 minus 416.67. 75 minus 416.67. Remember, you should never get a negative on your Easy ANOVA table. So if you do those subtractions on a row-by-row basis, you're going to be getting a bunch of negatives that you're going to add up. That's not going to work. So do the sum of first, do this fraction first, and what I've encouraged students to do on occasion, it's not on the table, go ahead and put that in parentheticals. Put an open parentheses before it, a closed parentheses after it. That's going to tell you do this part of the formula once, then subtract the g squared divided by capital N just once. So in that case, once we've done that, we get 47.33. We then are going to want to take that and drop that into our between subjects for the table. As I said before, to get the total, it's between plus within, just those two. How do I get this value down here, the error term? What I do is, because these are indented, they are subcomponents of this. So I take 68 minus 47.33, that gives me the error, or as the formula sheet says, take SS within minus SS between subjects. That remainder is your error term. This is going to be the denominator for your F statistic. So as before, the rest of the table is not too terribly difficult to fill out. I have little n minus 1. So in this case, we had 8 observations per level of the independent variable, so that's going to be 7. Then down here, it's basically just a rehash of the other formula. So 24 minus 3 minus 8 minus 1 is going to give us 14 for that value there. And then as before, in order to get mean square between, and now we want MS error. Before, with the one-way ANOVA, we were calculating MS within. That's not important here, so notice that that's an empty box, a blank box. We still need mean square between, so we're going to divide that 121.33 divided by the appropriate degrees of freedom 2. That's going to give us that value. Then we'll do the same down here. We'll take 20.67, divide by the 14 to get the mean square between. Once we've calculated those end up being 60.67 and 1.48. Then as before, This is our denominator. This is our numerator. We'll divide those together. We get an F of 40.99. Remember, F comes with the associated degrees of freedom. It's F for the degrees of freedom for the numerator and F for degrees of freedom for the denominator. So my F here is going to be 2, 14 equals 40.99 as you see on the screen. You'll need to look up the critical F value for that in your F table. By now you should be used to doing this. It's in the back of your textbook, or if you need to find it online, there are a number of F-crit tables online. When you look up that value, it gives you an F of 3.74. Again, reiterating with the ANOVA, we do not have two-tailed because basically we're squaring everything, so it ends up making that distribution one-sided. So it's not going to be plus and minus. It's only going to be plus 3.74. Our fail to reject region, our reject region, 40.99 clearly falls in the reject region. So this does indicate, as with the one-way ANOVA, at least one of the means is significantly different from at least one other, but we do not know which ones. So as before, we need to do the post hoc analysis of variance. We use effectively the same formula that we used before. The Tukey's HSD formula changes only slightly. We do still have Q times the square root, but instead of MS within, it's now MS error. So it's going to be this, again, our denominator term. That will be the numerator here. The good news is, with repeated measures design, at least at the level of statistics that we're dealing with here, you will never have to compute the harmonic n as you had to do with between groups, because with a repeated measures design, an idealized repeated measures design, you will have the same number of participants taking part in each condition. So the n per condition will always be the same. For us, it was 8 in each condition, 8 participants, so that denominator there is going to be 8. You will need to look up that Q value from the studentized range table. That works just as it did before. So you're going to have, remember the top is K, that's not degrees of freedom, and then you will have your degrees of freedom for your error term. You're always using your degrees of freedom for your denominator over here. So you'll need to find your Q value from the studentized range table. What I've done for you is, again, you should have some good practice at this point. I have left some blanks here for you to insert the 3 means, and then you'll need to do the pairwise comparison, the 3 means differences. Remember, if you have 3 means, you're going to have 2 plus 1 pairwise comparisons. So I've got those spelled out for you here, and then you'll need to compute your final Tukey's score after you find your Tukey's HSD value after you've found the Q value. So I encourage you to pause the video for a moment. And if you are back, as we look to fill this in, these will be the values that you would get. I've just changed the organization of the screen a little bit. Then remember, you need to indicate which ones of these are significant or not. So after you have computed the Tukey's formula, you should have plus and minus 1.738. So anything that exceeds that to the positive or negative side will be in the reject region, meaning those means are significantly different. So as we look at these, in fact, all of our values are well past that, meaning that all of the means are significantly different from each other. Now the important thing is for interpretation. For interpretation, you want to go back to the original means and look at those. Well, we start with an average of 1.5 errors, then we go to 4 errors, then we go to 7 errors. What does this ultimately mean? With sleep deprivation, there's going to be a number of errors, but that error rate is going to keep progressing at a statistically significantly level, even up through and after 60 hours of sleep deprivation. So this is a linear increase in errors, not a true line, but it is still a linear increase in errors at a statistically significant way at each step. So this video is a little bit shorter because repeated measures ANOVA is very, very much the same as between groups ANOVA. A lot of the concepts are the same. The thing that will come back to haunt you if you're being tested on this is calculating that between subjects line. So I encourage you to spend some time practicing that. Look at the formula, make sure that you remember the steps and how that is done. But ultimately, we have completed the repeated measures ANOVA, and we will be moving on very soon to a 2-factor ANOVA.